Alright class, today we're going to be going over thermal chemistry. Think of a thermos having to do with heat transfer. My voice is kind of iffy right now, so I'm going to have students actually say out the other slides.
Temperature and heat. Heat not same at temperature. Heat equals energy transfers to one system by another due to temperature difference. Temperature measures all heat energy contents and ability to transfer heat. Thermometer. Higher thermal energy, greater motion of constituents. Sum of individuals' energies of constituents equal total thermal energy. Nathaniel's awesome.
Alright, so the main difference between heat and temperature. Heat again is the total energy, while temperature is essentially the average kinetic energy of the particles, how fast they're moving.
Calculating heat transfer. Q equals C times M times delta T. Q equals transferred heat. M equals mass of substance. T equals temperature change. FYI, specific heat capacity of metals is very low. What does this tell us about heat transfer in metals?
So, heat transfer is having to do with how much energy transfers from one substance to another. Think about a fire burning. If the heat transfer is very low, that means it heats up very fast, right? Think about if you're cooking, say, fried chicken with oil, the heat of the pan will go up very fast.
Let's do an example. In your backyard, you have a swimming pool that contains 5.19 times 10 to the third kilograms of water. How many kilograms are required to raise the temperature of this water from 7.2 Celsius to 25.0 Celsius?
So in this question, we are looking at a big substance of water. Let me use a light color so you can see it better. Here I have my pool. I can't put water in here, so it's hard to see the blue in here. But we have this much water. We're going to raise the temperature of it by putting a fire under it. Here's my fire. We're trying to see how much energy we need in order to raise the temperature from 7.2 up to 25.
Q equals C times M times delta T.
So if you multiply those three terms, your C is your specific heat of the water. It's 4.18. You can look that up in your formula chart. The mass of the water in grams is 5.19 times 10 to the sixth. To find your change in temperature, you got to subtract your two temperatures. We started at 298.2. You subtract down to 280.4. Our final answer is 3.87 times 10 to the 8 joules. Key part to remember here, you need to use your temperature in Kelvin, okay? Now in the end, you'll get the same answer. You would just have different units in Kelvin instead of Celsius. But make sure you be careful what type of question it says.
But what if there's a change of state? Temperature consists throughout change of state. Added energy overcomes intermolecular forces. So
if you're changing state, for instance, say we're going to a solid to a liquid or a liquid to a gas, it's going to take energy to do that. However, the key part is the temperature is constant. Constant means it stays the same.
Temperature is in the vertical line, time is on the horizontal, and as you can see in the graph, the temperature is increasing.
Okay, so looking at this graph, you can see how at times my temperature will go up. That'll be the diagonal lines on the axis. If I have a line that is horizontal, I'm changing state. So the first change of state here will be a solid into a liquid. And this is called the heat of fusion. Fusion means to melt. Okay? The second line here is from a liquid into a gas. And this one's called the heat of vaporization. Think of the word vapor. Vapor means a gas. All right, in order to figure out the change of state, you want to look at the total heat transfer. It involves the amount of heat to melt the solid, then to go from a solid to a liquid, the amount of heat to increase the temperature of the liquid, change the state from liquid to gas, and then your heat if you keep increasing the temperature of your gas. Again, solid to liquid is the heat of fusion. That is 333 joules per gram. That'll be on your unit tests and your formula chart. Your heat of vaporization is, again, to boil it. It'll be 2256 joules per gram. That's why it takes a lot more energy to boil water than it is to just melt ice. All right, so that just about covers thermochemistry and what you'll see on your unit assessment. There is a few other questions on exothermic and endothermic reactions. Exo means the temperature goes up, or endothermic, the temperature goes down. Speaking of down, if you have any questions, leave a comment down below or shoot me a message.